Thank you, Matthias, and thanks, Maxon, for having us here. Thanks, everyone, for being here. Thanks for the guys who are watching from home, maybe from London, hello to our studio there, and to our studio to San Francisco, New York. We're a territory studio, as Matthias was saying. We just work in some films and products, and we specialize in visualizing interfaces and futuristic technologies. This is some of the behind the scenes, which I always find very relevant because it shows some of the Cinema 4D action and how we get to composite some of this. And today I want to walk you through some of those projects. So my name is Marti Romances. I'm a creative director and co-founder at Territory Studio in San Francisco. That's where we are now. We expanded to San Francisco a couple of years ago, but the studio started in London 8 years ago. Now the London office grow up to in a good day we will be 70 people. So it's starting to become like a bigger VFX company. We do VFX for films and commercials, but we started as a motion graphic company. And all of a sudden we realized that there was a window for us to work and apply our motion graphics into the film industry. So these are some of the films that we worked on this last years. The very, very late ones, like we had Avengers Infinity War coming up this last year, Pacific Rim, Ready Player One, and we have now in 3 days Mile 22, which is another production we've been working with Peter Berg and Mark Wahlberg. So as you can see, each one of those films require a completely different approach and different type of graphics. Some of those will need to be very realistic and grounded, while others will aim to have more of a futuristic vision and abstract visualizations, and that's the case sometimes with Marvel films. So I want to show you some of the work that we've been doing recently. Right. Thank you. So, at Territory, we help directors tell a story. That's what we do. We create graphics for them, and with those graphics, we solve some narratives that the directors need to solve for each different film. So we are designers, and we design to tell a story. And to do that, we use technology, and that's so relevant to be so connected to software developers like Maxon. Cinema 4D is one of our main, if not the main, 3D package that we use to create all of these films. And again, through the stories, we sometimes inventing new technologies. So for us, it's very relevant to be close to what's happening in the present, to be able to be more accurate when we're trying to speculate what's the technology that's coming next, and we are trying to invent for these future scenarios with Marvel and some of these directors. Again, we sit down in the middle of these two big industries, while the films and games allow us to reinvent ourselves and thinking out of the box, imagining things that might not be real or might not necessarily need to be something that's functional. These allow us to be a bit more disruptive when we're actually talking to products and prototype and experience clients, that they need that approach of being a bit less restricted and being able then to disrupt into their ways to visualize things or to tell a story. Again, we're here today to talk about how we use Maxon. And I think in the past we had, and Siggraph and some of the other conventions, we had like very, very heavy lifting Cinema 4D artists. Our head of 3D, Peter Essenyi, or like Nick Lyons, or in the past like Nick Hill. These guys are the guys that are going to be dealing with big cinema files and big 3D technical solutions. What I want to do today is show how this is software that can be used as a tool for not only these heavy lifting productions, but also as a designer myself, how I found cinema 10 years ago was helping me, and it's been helping me and other artists as a tool that might not require lots of deep learning, and it could be very easy to create things that visually are solving a problem. And that's why I want to just like talk about how we are going to be using cinema today as a design tool. And this could be applied to illustrators, to the artists, people that might not be just like or require this advanced technical knowledge of the software. And I think that's the value on what we're going to be looking at today. I'm going to look at 5 quick widgets and little things that we used in some of those films. This one, and I made those titles up. So these ones I call Tracing Orbs. And this is, I want to show some of the breakdowns on how some of the screens that we create, where they start. So with something as simple as a tracer object in cinema, we created those lines, and then within the compositing software like After Effects or Nuke, we just like can use those renders to mix them up. And I want to talk also about this orb that you see here in the middle and how easy it is to create a visualization like this. We can see it here functioning on the top. This was for Avengers Infinity War, and it's exactly using the same technique, just tracing those orbs to create those core visualizations of data. So I want to quickly jump into cinema and show you how we get this done. As you can see here, this is pretty much what it is. And let me just display. This is what we're going to be looking at. It is also like a very quick render because we have a hair material. So if I click render, it's automatically rendering. So I want to build this quickly to just show everyone how easy it is to create something like this. But also, if you get to a shape that you like and you want to bake that, you could also bake it, and that's the case here. You could also bake this sphere and rotate the element if that's what you need for that visualization, for example. So, and this is something that renders in less than a second. So it's not that we're looking at heavy renders. Sometimes when we're working with some of these directors, we need to be very reactive on how we change things on set, or we change things for a pre-visualization that that is going to change through the story. I'm going to just quickly create this, and the first thing that we need for this will be a sphere. To get a better distribution of points, we like to choose an icosahedron. As you can see here, the points will be distributed a bit more in an even way. We can add segments to this. What we're going to be doing pretty much is selecting some of the points. This sphere has this point selection. And this point selection is allowing us to trace those little, those little clone spheres, and that's what we're tracing. So it's as simple as that. You just trace those selections, and then you hide the sphere. You got that effect. Again, let's not stay here for too long. Let me jump into the next one. The Falloff Graphs. This is something that it could be seen as a 2D graph that we did for the Martian, and for this we had to be very accurate on where the angle of the wind was coming from. We could have achieved that with the 2D software, maybe yes, but not as quick as we could achieve this effect with cinema. So I want to just quickly jump into that and show you guys how that works. You can see here what this is. We have a controller, and I want to show you how this works, that will allow us, and again, this renders extremely quick, and it's seen as a 2D element. But I want to show you how this is done. If I change the perspective, you can see here how, this is half a sphere, and how we're using, again, the cloner, and, another element, which is the fill, not the fill, like the plane effector, and how this is affecting the areas that we wanna control. So I want to quickly show you. This time, I'm hoping it's gonna work everything well. We start with the sphere. Again, we want to see the vertices of this sphere. So to have a better distribution, we change this to icosahedron, and we add some segments to have a more density on those. And what we want to do is just, again, is exactly in the same way that we were creating the other widget. We just create some spheres that will be cloned around that. To do that, we select object, and we drop the object that we want to clone into that sphere. These spheres are massive, so what I'm going to do is just change this to 1 centimeter, and automatically you can see that this is being cloned. Because we are not interested in seeing that sphere, I can just drop a black material to see the spheres only. If I was to hide this sphere, we'll see through the sphere, and that's not the effect that we're trying to achieve here. So, and also because we're trying to create a 2D visualization, I can just go and change the camera to a top view, and that way I'm going to always have the exact angle that we want. But what we want to do is create this plane effector that as soon as I drop it here, you will see how it's affecting, in this case, the position. I didn't have to drop my effector to my cloner because I already had that selected. If that wasn't the case, I have to just drop this plane effector here. And as you can see here, this is affecting this parameter that we have here, tick. It's the y-axis of these spheres. That's not what we want. What we want is to have a scale that, as you can see here, let me just turn this off. As you can see, then the plane effector is scaling all the spheres. This is the effect that we want, but we want to restrict that to the angle that we want to have selected. So to do that, we have the fall off. And that means if I select a spherical fall off and I move this sphere to 100 centimeters to the side, to be exact, then we can see how this is starting to create the effect that we want. Something as simple as that. It took no time to do that. But we also want to create the other bit, which is the outside. So I'm going to just collect this and call it the inside, and show you how we're going to create the outside. The outside is another, cloner. In this case, what we want to clone are those little sticks. So we're going to start with the cylinder, as you can see here. And as soon as I drop this cylinder to my cloner, that's going to be cloned as a linear format. What we want is a radial format, and change this plane to have a frontal plane. We already see how these cylinders are too big, so what we want is just to select different radios, make sure that those guys are smaller, and we can even get to see where it is at the in, so we can just make sure that the sticks are gonna be cloned around it. We could even because we know that this is 100 centimeter sphere, we could just say let's give it 10 centimeters of of offset. Again, the same thing will happen here. What we want is to be scaling these elements at the same time that we scale these spheres. So the only thing I want to drop here is another plane effector. In this case, this cloner effectors, that's it. That's affecting the cloner. In this case, we don't want a uniform scale, but we want, let me hide this. We want to have the out scale. The first thing that we notice here is that these cylinders are scaling from the center, and that's not the effect that we want. And let me show you why. Because when I drop this fall off, this exact same that we did with that with the spheres. If I drop this fall off and I put it to 100 centimeters to the side, as we can see, these things are being scaled also to the from the inwards, and we don't want that. Well, the best way to just solve this problem is, let me go outside of this cylinder. I can make it editable, And as soon as this is editable, I can change the point of the axis to start from the very bottom of that. As soon as I drop this back to the cloner, now you can see how we're starting to get the effect that we wanted. These things grow from the tip. And also the nice thing about the fall-off is that you're going to have control of how this gradient is affecting that selection. Therefore, then at this point, we can just play with how big this fall-off is, how much is affecting that side, and whatnot. And the other thing that I want to just like, the other thing that I wanted to say is like, then these you can be changing those if you want still while this is animated, while this is moving. Talking about animation, then we might want, the director will be very specific on where he wants these points, or maybe we want to do this in a way that it could be interactive on set. So the way to do that is just to get those two plane effectors to a controller. And a controller could be something as simple as a circle, which I'm going to put at 100 centimeters again to keep it all tight. What we want to do is attach these plane effectors to that spline. So if I go to my Cinema 4D tags, I go to attach to spline. I align to spline, sorry. I can then see those two tags. As soon as I drop my circle that I can call controller, then you can see here the spline tag. Like I can just like drop the controller for both of them. And that means like when I move this controller, that's actually going to be moving both of them, not only one. And that's, and that's also giving us like the effect of like being able to play with whatever rotation, position, and everything. It's going to be connected. So again, something extremely simple to create, and that's that is very powerful on how you can do these visualizations that end up in those big films and end up solving some problems. The next thing that I want to talk about is the step effector and time offset. Again, is another way to use the cloner and offsetting some of those splines and graphics. This was used for Guardians of the Galaxy, as you can see. It's a very simple effect. As you can see, is down below this hexagonal movement being very organic and being, something that is pulsing. This is thanks to being able to offset the time of these graphics. And again, back to, this is seen as a 2D element, this is seen as a 2D animation, but it's all done in Cinema 4D. So let's jump right into it. So just to show how this works, this is the same project that you were seeing there. There's a scale, there's rotation, there's different things happening here, and it gives you this sort of very organic movement. Even if it was for an illustrator, even if it was for a designer that's trying to get this shape, that's only having, being able to do that in less than 5 minutes. That's good for any designer. And also you can play with other things, which is like not only changing the size, but also rounding those elements to different shapes and getting that organic feel. I'm going to go quickly again how we can achieve that. We're going to start with this spline. I can then select, let's say, we start with a pentagon. And what we want to do is go back to the MoGraph clone that spline. Automatically, that spline is going to be cloned in the y-axis, as you can see here. That's not what we want. Actually, we want lots of clones without having any scale or position change. And what we want to be doing is animate this spline. So let me just take that out. I'm going to just animate this spline. Going to the coordinates, I put a keyframe for the rotation, and I animate this rotation to go let's say, 180 degrees or something like that. I animate this with another keyframe. I also can scale it up. So I'm just doing this quick animation to show you guys, how that will react later on. And now that I have this spline, I can just drop it into a null, so the cloner gets that animation. And for you guys to see what's happening here, let me just go back to show how all this animation is here, and it's cloned. What we want to play with in this case is the step effector. Again, we just drop this step effector into that, and automatically the step effector is affecting that cloner. In this case, it's in the parameter of a scale. which is fine. But if you wanted to, let's say, get to another view, you could like punch it like this, and then you have like the same effect but in 3D. So and then that animation is just like offset in scale and in position. I'm going to turn position off, and I'm going to see this from, again, a frontal view. Because the nice thing about the step effector is that even if you're not affecting any of those scale or like, we have down here the time offset, and that's what we're using to create these organic animations. I can just like say offset the animation that we just created by 15 frames, and all of a sudden, as soon as I click play, you will see that we're getting that effect of these animations being offset in time. Super simple, to the point that also is parametric. So if I wanted to, again, animate the amount of sides or the rounding, we can just do that right now. I animate this radius from 0 to, having these round edges. And as soon as I play it, you will see when we get to this point, that's round the edges to, even to a complete sphere. If we round it completely, you can see how then that will affect all of them with this time offset. And again, this is parametric. You still have the spline, and you can then use the spline to whatever you want to do. You want to be driving some particles to it. You want to be just extruding that, or creating booleans, creating whatever you want. And this is right on, like how we created this little thing here on the bottom for Guardians of the Galaxy. And again, yes, you can do this with a 2D package, but if you can do it in less than 5 minutes instead of 4D, and then also this adds the parametric options that then you can just modularly combine with other things, then that's perfect. Again, talking about combining with other things, I want to talk about how some of these little, very simple things, when they are combined all together, create very, very complex and detailed designs. Like this one that we did for Marvel. This was on the concept early stages, trying to, simulate the data core. As you can see here, this same thing end up in so many screens for Guardians of the Galaxy or Avengers. Like all these intricate things are different, very simple layers animated in Cinema 4D. It takes no much to learn this in less than 10 minutes, and that's why I want to go through it. As you can see here, the final result is again seen from a frontal view, so it's seen as a 2D element, but it's really created thanks to the depth on the 3D and some of the things that we can achieve with Cinema 4D. And I want to jump right into it. I don't want to just get too deep into how many things you could create with this, because I think the nice thing about these projects is that you learn something very simple, and then you can go home and combine it with whatever you want. This is a file. As you can see, this is it could look a bit complex, and it's not really. And you will get to know right now why this is not that complex. When we render, it's a quick render. It's something that is looking very futuristic. You have these little particles. There's no particle system here. And I want to show you why, like how we're using some of these techniques. Again, from the front, is seen as one of these widgets. So let me go quickly through some of these points. Starting with the first one, which again is extremely simple. This is a cylinder. Sorry, this is a tube, as you can see here, that has been sliced. So as you can see, this tube has been sliced here, and we use that to animate this in. As you will see here, the animation is some rotation, and the slice is opening. Again, if I render this is just like, half a cylinder. But as soon as I drop this into an atom array to get like the vertices and points, you will see here that we start getting this sort of a particle-looking system. Now, guess what? If we drop a displacer in here, then what we're creating is like displacing all these polygons. That might not be just like the effect that you're looking for, but as soon as you drop the atom array, then you have this sort of a randomized abstract particle system there. The good thing about this is like the displacer maps are allowing us to have animation in here. As you can see, it's not the rotation, it's like the animation that all of this noise is and the turbulence fields are affecting to it. If I go to the field, to the shader, you can see that this wavy turbulence has like an animation speed of 1. And again, it's going to give us this look and feel, but I can change the noise to be something completely different. I can go into cell noise, and all of a sudden you have this different animation happening, and completely different looks that is more blocky and gives you a completely different effect. Again, it's still parametric, and it's super simple. You are displacing a tube or another object, and you are dropping this atom array to it. And you will see that for these other passes, it's pretty much the same thing. In this case, we're using the atom array, selecting like the cylinder radius being like something slightly chunkier, so we can get this wireframe mesh out of this. And it's exactly the same thing. It is a tube. In this case, this tube, has some more like density here, because we can change, again, we can change whatever we want on this. We can round it. We can just add whatever we want, and then we're just displacing it and throwing this into an atom array. And that's the second layer of this. Just combining those two, we'll already have a very complex look and feel. The same thing happens here, more displacing, more tubes. And then another one, which is like, this one is just this pass with two cylinders that are just being animated in and moving around. These are two tubes, sorry, that then, again, if we wanted to animate them, you can just go into the inner radius, outer radius, or animate the spline. We can just make this being another layer of this complex visualization. And it's extremely simple to create, these two tubes. But when you combine them all, then is when you have the good result. This one, again, is cloning a tube with this random effector. If I unclick this random effector, you will see that I have this tube, which again, it has a slice, right? And I'm cloning it, a bunch of times, 16 times. The only thing that I'm doing is adding this random effector that, as you can see here, is affecting the scale. So when I do this, then I have this little multiple cylinders being seen. And the good thing is that I can still add more to it. I can offset them if I want to just animate this rotation in a more organic way. I can just change the radius, but then in this case, that's not the effect that we will want. Or I can either go back to the this random effector and animate this in if I want it. So again, super simple. You drop a tube, you slice it, you drop into a cloner, you add a random effector, and that's the effect you get. And the same thing happens here. Again, more super simple stuff. We have all of these cloners here. Let me just focus on one for now. This cloner has a sliced tube, as you can see, creating these little blocks. And this cloner is being affected by the same random effector that we had before. So if we had to animate this, all of them will animate at the same time. Extremely simple. And when you're just looking at these things, you will think this is complicated. It's not really. So this is, again, going back to Keynote quickly, because I don't want to just spend too much time on this thing. This is how we get effects like this that will be seen as something a bit complex and all these systems, but they're extremely simple layers just combined and creating this a bit more of a complex animation. Again, from a designer point of view, because this is not requiring extreme knowledge on a 3D package. This is for designers as well. And that's the point that I want to, I like for you guys to get through from today's presentation. Again, created a Vortex. This was done for Infinity War, for the new Guardians of the Galaxy spaceship. These guys are going into time travel. We have some artists here that helped me and others with this project. So this, as you can see, is a very simple visualization of a vortex that it will take a little bit of a long time to create in 2D. So let me just quickly show how that was seen from this, from Cinema 4D. And I'm not going to go too much in detail because I still want to touch on a couple of things. But as if I press play, and I will say this is a slightly more complex way to operate, because these particles are being emitted from this circle, and they are shooting through the camera. And then there's a wind, affecting these particles and creating this turbulence. So let me just I'm just leaving it loading a little bit because it's the first time. But if I click render, bam, it renders extremely quickly. We can grab this, we can put it into our compositing software, play with the colors, and we will get to do, we'll get the exact same effect. But if you look at this, if I change this camera, as you can see, when we see this from the side, this is just done with some thinking particles, and again, cloner. As you can see here, this cloner is cloning this little tube and little cube that if I just want to see it from the side, you will see the exact same things. But when you change your point of view from a very defined angle, you get this effect. Again, I'm not going to go through how we get to do this. I think it's extremely simple to create particle systems as well within Cinema, and then playing with thinking particles. But I just want you guys to get the point that just to create this thing in the middle, that's what we use. And it was very easy and quick to do. And we could iterate, and then we can later on change things in After Effects or in Nuke, changing the colors, changing the displacement, and different things. I want to talk about this a little bit as well, how we prepare some render passes. And for that, I want I want to share with you guys some of these breakdowns on how we get to create some of those screens, seeing them from the beginning, and kind of breaking them down on all of these different elements. Because for us, it's very important that once we are on set with the directors and production designers, and even when we are trying to visualize something with them, and they're sitting next to us and they want us to change something, we cannot afford to then say, oh, let me render this again, wait 2 hours, and you will have it. They want to see it there. Sometimes you will have actors that they are, very expensive to have in that scene waiting because they wanted you to highlight a different point on this 3D. We don't have the luxury to say, oh, let me just go and render farm this out. So what we do is we just segment all of these layers that you will see here on all of these different passes, so we have more control later on without having to re-render those scenes. And it's extremely simple, right? It's going to be selecting some of those points, creating masks, and then being able to add more color, change the color, add, tweak things into these different passes, and get into these visualizations, that, again, those renders will be seen as something mega, but they are not really. And let me just quickly jump into how this is seen from the compositor view. In this case, we have this thing here. Let me just actually show you guys how this works. So then we added all the UI and everything, but we start from rendering these elements in Cinema 4D and rendering these different passes. And then because we have all these different passes that I can just show you, we can then quickly just change the color, change the transparency of this. We already have all these passes rendered and all these animations. You can see here how we just rendering from different colors, different reflections, glass pass, X-rays, wireframes, different ways just to visualize these elements, and how later on this will let us play with it. And that's what I want to show you today here. If I just go into here, I can start showing you guys how we can solo these things, and you will see what I mean. These passes are different and they are all separate, and they, it looks. Okay, sorry about that. Sorry, he's asking for an AI. Okay. So I would just want to show you quickly how just getting into one of those passes and changing the color can affect the whole design. Sorry about that. I should have checked this. So yeah, let's go into this bus and let's just grab maybe these lines. These lines are already being toned into a color. But let's say that we want just to change these because something bad is happening. As you can see, we're already having a completely different look. Maybe we want a warning sign next to it, something wrong is happening. But we have all these already rendered, and then that means we can just play with it. We can just change the whole, the whole value of this. Maybe we're next to the director and he wants to try something else. We don't have to go back and render things, and that's why then it's so important for us to have this versatility with Cinema 4D rendering different passes, because then we can get to do these things. And again, this goes also for some of the lines, some of the point clouds that we get from the cell render or hair render. They're extremely fast renders, but when they are all combined, they create something that is truly like impressive to some of these guys. And we did the same thing here. Let me just quickly open this wing screen just to show you that you can then select different points of this very intricate model. And we might want just to focus on this part of the spaceship, but then we might want to just like render this section here as an object buffer, and that will allow us to then, without having to re-render, highlight something in that in that project. And I think that's pretty important for, at least for us, that we have to be very reactive. And might not be the same for a VFX pipeline, of course, but for the designer to be able to iterate and go to the clients and go to the directors and show these things is extremely powerful. So we can just like quickly also open a couple of other things, but you'll have this, and you have the ability to then also like look at what's highlighted, what's pulsing, just because we could render these different passes. So if I go to this wing, you will see here how I can select this thing, and this can be like quickly animated within our compositing software without having to render some of those things. And what I was saying, you can change the color later on. You want this highlight to be blue. There you go. That is blue now. It takes nothing. And so that versatility and having different scenes within cinema is great. And the last thing, again, how some of the stuff that we've been creating, let me just go back quickly to my keynote. Some of the stuff that from Ready Player one of that scenes that you guys will recognize, that was all created within Cinema 4D. And I want to just show you a little bit of the process and how some of these, this particular scene, it's all done in Cinema 4D. You will see here some of the early stage and some of the concepts. I believe like the London office ended up working on 260 versions of this. But all of these was allowing us to quickly iterate with the director and showing them, showing everyone there what it could be done. Even things like the Ready Player One or the Oasis titles for that intro were created in Cinema 4D. So as you can see here, some of the early previous different options on how we get through that intro, all done in Cinema 4D. So again, from the knowledge of a motion graphic artist jumping into some of these tests and some of these things, it's truly awesome that we're integrating all of this through all these film pipelines. So before I jump up on this, I want to open that file. We have a couple of different files here, but I'll just opening this for you guys to realize that some of these things is something that you guys could be doing at home. Maybe that will be a bit of a more complicated scene. As you can see, there's lots happening here. But it is, at the end of the day, lots of, again, what we see here, a step effector. Oh, look, a random effector. Oh, wait, a plane effector. These are things that we just discussed like 30 minutes ago, right? And those things are being implemented into the way that, the designers at the studio and everyone works. You can see this is the tunnel, and it's just like flying through. So I found that these things are relevant to also artists that want to have an early, a bit of a more easy in access into a 3D package. Cinema 4D, by all means, is the most friendly user interface that you can find as a non-3D artist to start getting to some of these solutions. So, I mean, I could be here for ages, but I think we don't have much more time for it. So I would say you can reach me on Twitter, Marti Romances, or I'm also like on Territory Studio. Feel free. We like feedback. We like people just to ask us questions and send your works and send what you guys doing, because I think, again, like we really value like how designers get out of their comfort zone, and Cinema 4D is for sure like one of the best softwares to just getting to 3D and getting to do some of this stuff. So I would say thank you very much. Thanks everyone at home. Just come check out our website. Thanks for coming. All right.